Hi, in this video, I'm going to talk about section 9.2 from the book, okay? So which is infinite series. In section 9.1, we talk about infinite sequence, meaning that there are infinitely many terms and you write the terms separated by commas, right? And we talk about the convergence of the sequence. We talk about different techniques to show the convergence. We talk about the boundedness of the sequence. We talk about the monotonicity, like increasing or decreasing sequence, and so on. So on this section, we will talk the sum of those infinite sequence, okay? So the sum of infinite sequence is called infinite series, all right? So sum of infinite sequence is called the infinite series. You see that? And here a1, comma a2, comma a3, comma a4, that so on. These are the terms of an infinite sequence, right? But if you write them in the sum form, if you add them, then you get a1 plus a2 plus a3 plus, and then keep doing that. So what do you get in the short form? You can write sum. This symbol is called sum, okay? This is like summation. We call summation. N equals to 1 through infinity a sub n, which is plug in n equals to 1, you get a1, and then plus, because this is the sum, right? Plug in n equals 2, that is a2 plus a3 plus a4, and so on. So that is called the infinite series. So infinite series. Okay, now, so there is another term that we use in this chapter is called partial sums. So what is the meaning of partial sum? Partial sum is the sum of first few terms. What do you mean by few? We denote by s sub n, that is a sum of first n terms, okay, starting from 1. That is same as we denote by s sub n, which is n equals to 1 through n, okay. A sub n, what does that mean? That means a1 plus a2 plus up to an. So if we say s20, that means a1 plus a2 plus a3 plus up to a20, okay. So if we say s5, that means a1 plus a2 plus a3 plus a4 plus a5, and so on. So Sn is the sum of first n terms, okay. So sum of first n terms, that is called Sn, okay. That's the partial sum. Sn is that S1 will be just the first term, S2 will be A1 plus A2, S3 will be A1 plus A2 plus A3, S4 will be A1 plus A2 plus A3 plus A4, and so on. Keep doing that, okay. So find out S5, S6, S7, like that, okay. So if you set like S1, S2, S3, S4, S5, and so on, so this becomes the sequence of the partial sums, right? You see that? As we define sequence in this section 9.1, A1, comma A2, comma A3, comma A4, A1 is the first term, A2 is the second term, A3 is the third term, and so on. Similarly, we first found the partial sum starting from S1, S2, and then S3 and S4, and so on. Now if we put them together, this is S1, comma S2, comma S3, comma S4, comma S5, and so on, right? This is called sequence of partial sums, okay? Sequence of partial sums. Partial sums, okay? So this is called sequence of partial sum. We denote by Sn and then parenthesis, okay, which is same as S1, comma S2, comma S3, comma, and so on, okay. Now, so we see that in section 9.1 we talk about the convergence of a sequence, right? And we talk different techniques to show the convergence of a sequence. So what was the definition of convergence of a sequence? A sequence is said to converge to a limit L, or limit of a sequence, okay. As L is called the limit of a sequence if all the terms of a sequence after certain terms are getting closer and close to the number L, right? Similar to that, how do we decide what is the convergence of a infinite series? What is the convergence of this infinite series is if the sum of these infinite series, or if the sum of all of these terms, infinitely many terms, is a number, a finite number, okay, that is basically the sum of the series or the infinite series, and in that case we call that series converge. Series converge means the sum of the all of the terms is a finite number, okay, that's what we call series converge. Now, how do we define the convergence of a series, infinite series? Is if the sequence of partial sums Sn converge to S, because we know how do we show the sequence of a sequence converge, okay, we know how do we show the sequence converge. Now for the infinite series, the infinite series converges if the sequence of the partial sum, if Sn converges, okay, if the sequence Sn converges to S, then the infinite series converges to the sum S, okay. The limit S is called the sum of the series. That is, if limit n tends to infinity Sn is equals to S, a number S, then the summation of all the terms, or the sum of all the infinitely many terms of the series converge to S, or the sum of that series is S, okay. If the sequence Sn diverges, then the series An diverges, the infinite sum of the sequence diverges, that is, it will go to infinity, okay, that's what it says. All right, now you see that example. Let us see that. Find S1, S2, S3 of example 5 and 7. Okay, let's do that. What will be S1 is just the first term, 1. What is S2 is the first term and the second term, right? How much is that? 1 plus 1/4. How much is that? So that is 5/4, right? What is S3? S3 is first term plus second term plus third term, right? So it will be 1 plus 1/4 plus 1/9 is equals to, if you by the way, if you find out this one, this will be almost equal to 1.25, and if you use this calculator and find out this sum, that sum is almost equal to 1.3611. okay, let's find out S4, because it asks up to S4, right? S4 is the sum of the first four terms, 1/4 plus 1/9 plus 1/16, okay, that is 1.4236. that's what you get if you add the terms, okay guys. So in that way you can find out all the Sn's, right? S5, S6, S7, like that, okay guys. So the next thing I want to do is example number 7 from question number 7 from the book. That was question number 5 from the book. What is S1? S1 is 3, right? What is S2? S2 is 3 minus 9/2, right? 3 minus 9/2. Let me write down there again, 9/2. If you use calculator, you will get negative 1.5, because 9/2 is negative 4. This is negative 4.5 plus 3, that is negative 1.5. What is S3? S3 is 3 minus 9/2 plus 27/4. Okay, what do you get if you use calculator for this? You will get 5.25. that's what you get, okay. Similarly, find out S4, that is the sum of the first four terms, that is 3 minus 9/2 plus 27/4 minus 81/8, okay. If you use calculator, you will get negative 4.875, 4.875, and so on. So you can find out any Sn by these techniques, okay. But the problem here is we want to find out the infinite sum that has infinitely many terms. So we cannot add like term by term like that, because there are infinitely many terms. So we will be learning in this chapter, we will be learning about how do we find out infinite sum of a series, okay, or how do we find out infinite sum of a sequence in a shortcut way without adding like one by one. That's our goal in this chapter, okay. Let us see one interesting example there. I want to find out the infinite sum of this sequence or this series. I want to find the sum of this series, okay. So how do I do that? There is just a very basic or algebraic way. I'm not using any type of like complicated formula here. What I'm going to do first is I want to simplify that. You have summation n runs from 2 to infinity. Do you know why n is running from 2 to infinity? If you said n equals to 1 to infinity, then you will get 1 minus 1, 0 in the denominator. So it will be infinite sum. That will be infinity. Okay, so it diverges at that time. So I'm just starting from 2 to infinity. Now I want to do the partial fraction of that. So I want to do 2 over n minus 1 times n plus 1. That's what I want to do there. Okay, guys. So, and I want to do the partial fraction there. So this is equals to summation n equals to 2 through infinity, right? It can be written as 1 over n minus 1 minus 1 over n plus 1. Do you agree with this? If you simplify this, in the denominator you will get n squared minus 1. In the numerator you get n plus 1 minus n plus 1. That is same as 2 over n minus 1 times n plus 1. Now, what I want to do, I'm not using Sn thing, okay? I'm not trying to find out what is Sn here. Okay, guys? So what I'm trying to do here is basically I'm trying to do here just the algebraic way. Because later we will see that to find out the sum, we'll find out the Sn, and then we'll find out the limit of Sn. That's later we will do that, okay? But for now, so I'm just doing very basic method, okay? This is what I did. We will call this as a telescoping series. What that means is if you plug in 2, what do you get? If you plug in 2, you will get 1 over 1 minus 1 over 3. Does that make sense? Now plus plug in 3 for n. You will get 1 over 2 minus 1 over 4. Let us plug in 4 for n. 4 for n, you get 1 over 3 minus 1 over 5 plus, let us plug in 5, 1 over 4 plus 1 over 4. Let me write down the plus, just 1 plus there. Okay, so this is 1 over 4 minus 1 over 6, because if you take n equals to 5, n plus so on, so many other terms. Let us look at this. You see that? Did you see something interesting here? Okay, what is happening here is, you see that that's 1 and 1 half do not have any pair here, but 1 over 3, that 1 over 3 is negative. There is positive 1 over 3. Now that is negative 1 over 4, positive 1 over 4, negative 1 over 5, there will be positive 1 over 5 here, and negative 1 over 6, positive 1 over 6 come here, and so on. If you continue that way, all the terms except this 1 and 1 half will cancel out. It will telescope, meaning that one term on the earlier cancel with the another term on the later. Okay, so it's in that way all of the terms will cancel out. Only 1 and 1 half, you don't see that anymore. So what is left is 1 plus 1 half is left. Okay, all other terms will cancel out to the terms that comes later. So what is the total sum then? 3 half. Isn't that interesting? You are adding many, infinitely many terms, and you are getting the sum just 3 half. Okay, so the sum is 3 half here. The sum is 3 half. Okay, guys, on this problem. So the infinite sum is 3 half. Okay, so next we will introduce a geometric series. Okay, and then we know the formula to find out the sum of the geometric series though. Okay, and then in that way we will find out how we use geometric series formula to find out the infinite sum. Okay, guys. All right. Okay, so here, so let us first, before we go to the geometric series, let us first talk about the geometric sequence. Okay, a sequence of this form: a times r, a times r square, a times rq. You see that a is same for all of the terms, but the exponent of r is like r to the 0, r to the 1, r to the 2, r to the 3, and so on. This type of sequence where the exponent of r is increased by 1 for every term, okay, is called the geometric sequence. Okay, now you see that what is the ratio of AR and A? You see that AR divided by A is just cancel out, so R, right? Similarly, what is the ratio of the third term and the second term? You have AR square over AR, that is also R. You see that? So in a geometric sequence, the ratio of the two successive terms is called common ratio. Okay, here the common ratio is R. So for any two successive terms, you can do first and second terms, the ratio of the second term divided by first term, third term divided by second term, fourth divided by third, or 50th divided by 49th, or 100th divided by 99th term, and so on. You will get the same constant value R in the geometric sequence. Okay, that R is called common ratio. Now if you add all the terms of a geometric sequence, we called geometric series. So the shortcut notation for that is n equals to 1 through infinity, AR to the n. That means if you plug in n equals to that should be 0 to, right? Because you see that, because it has A, so you should write 0 to n equals to 0 to infinity, because if you plug in r n equals to 0, you will get just A times r to the 0, that is A, and n equals to 1 will give you AR, n equals 2 will give you AR square, and so on. Okay guys, so this is the geometric series. This one is the geometric series. Now for the geometric series, there is a definite convergence criterion. There is a certain criterion that the sum of the geometric sequence or the geometric series has a sum. Okay, has a finite sum, or in other words, we say that the geometric series converges to a number with certain condition. What condition is that? We will find out that now. Okay, so let us talk about this convergence of a geometric series. A geometric series with common ratio R, that is the common ratio, is given by A plus AR square plus AR cube plus dot dot, like that, so many other, right? Now, so what is Sn? Sn is the partial sum with n terms, right? First n terms. So n terms will be, first term will be A, second term will be AR, third term will be AR square. You see that for the third term, the exponent is 2. For the fourth term, the exponent is 3. So for the nth term, the exponent must be AR to the n minus 1. These are the sum of first n terms, that is denoted by Sn. Okay, if I multiply by R to each of those, I multiply this by R and then whole this by R. Okay, if I do that, you will get, on the left side you get R times Sn, on the right side you get AR plus AR square plus AR cube plus AR to the fourth, and so on. The last term will be AR to the n, because I'm multiplying by R. Now subtract Sn minus Rsn equals to, you see that A will stay A, but you get AR minus AR, because all of them will be subtracted, right? AR minus AR will cancel out, AR square and AR square cancel out, AR cube and AR cube cancel out. So you see that all of them will cancel out, but the AR to the n will not cancel out, because it doesn't have that cancellation pair, right? So what you get when you subtract is A minus AR to the n, that is on the right side. Okay, now what you get here is Sn minus Rsn in the left side. If you factor out Sn, you get 1 minus Rsn equals to, I factor out A because both of them have A times 1 minus R to the n. Now divide by 1 minus R. What do you get? You get Sn equals to A times 1 minus R to the n over 1 minus R. Now, to find out, to see the convergence of a geometric series, we find out the limit of the sequence of partial sum, right? That's what we define the sequence. If the sequence of partial sum converges, then the series converges. Or if the sequence of partial sum has a limit, then the sum of the series will be that limit. Okay, and we call converge. Okay, so that's why I'm trying to find out the limit of Sn. Limit of Sn is limit of that. Now if this R, if this quantity R is less than 1, okay, let's say 1/2, then what happens when n tends to infinity? Then you will get A and then 1 minus 1/2 to the infinity divided by 1 minus r. It's like, looks like that, right? And then this, you see that whenever you increase the exponent of a number less than 1, like 1/2, 1/3, 1/5, like that, it is true for any number between -1 and +1. If you increase the exponent of a number between -1 and +1, that exponent, the increased exponent, make the number smaller and smaller and smaller. For example, what is the exponent of 1/2? What is the value of 1/2? 0.5. What is the value of 1/2 square? That will be 1/4. That is 0.25. You see that? 1/2 cubed. That will be even smaller. 0.125 and so on. Okay, so if you increase the exponent for a number between -1 and +1, then the value gets closer and closer to 0. Okay, so at that time, when n tends to infinity, this term will go to 0. Okay, that is, this term will go to 0. So what is left is a over 1 minus r is left, meaning that when r is less than 1, then the sequence of partial sum converts to a over 1 minus r. That is, at that time, the sum of the geometric series, right? Sum of the an or r, you can write ar to the n. Let us write that way, ar to the n, arn. So n equals to 0 to infinity. It is a over 1 minus r. When? If r is less than 1. Now, what happens if r is greater than 1? If r is greater than 1, this term will be infinity, because it's greater than 1 to the nth power, and n tends to infinity. That will be infinity, and there is negative sign. Negative infinity over negative, this will get negative sign on the denominator because r is greater than 1 in the second case. So that will become s, and limit of Sn tends to infinity. So the geometric series diverges. If r equals to 1, that also infinity. So what we got here is basically the geometric series with common ratio r converges if the r is less than 1 and diverges otherwise. Okay, and what is the, if it converges, then what will be the limit, or what is the sum then? It is a over 1 minus r. It is a over 1 minus r. Let us see that theorem, which tells exactly the same thing. A geometric series with common ratio r less than 1. What does that mean? That means -1 is less than r is less than +1. That's what it means. Okay, absolute value of r less than 1 means it is 1 unit distance from 0. That is between -1 and +1. Okay, is less than 1, converges, and the sum is a over 1 minus r. That is summation of n equals to 1 through infinity ar to the n, 0 to infinity. Okay, ar to the n equals to a over 1 minus r if mod r is less than 1. Absolute value of r is less than 1. That is if value of r is between -1 and +1. Okay, let us look at this example. Test convergence for this series. Okay, is this a geometric series? Yes, because it is like a r to the n format, right? So we write it is a geometric series GS with r is what? R is 1/2, which is less than 1. If r is less than 1, then the geometric series converges, right? So the series converges. Where does it converge? What would be the sum? It will be, and the sum is a over 1 minus r. What is a? A is 1 here, right? So it is like a r to the n. That's why. So a over 1 minus 1/2. How much is that? 1 over 1/2 is basically 2. You see that? The summation of all the infinitely many terms in this series is basically 2. It does not exceed 2. It will be closer and closer and closer to 2. If you find out S1, it will be 1/2. S2 will be 1/2. So this is basically, let us see, I think it is 0. Okay, so 0 to infinity. 0 to infinity. If you plug in 0, you get 1, right? If you plug in 1, you will get 1/2. So S1 will be 1, S2 will be 1.5, S3 will be 1.75, and so on. So it will go to 2 if you find out many sums. Okay, many S1, S2, S3 like that. If you add all those terms, it will be 2. That's what he's saying. Okay. Next is test for convergence of n equals to 1 through infinity 5 3/2 to the n. What do you think? Is this a geometric series? Yes, it is a geometric series with what is r? R is 3/2. Is it less than 1 or greater than 1? So if there is a geometric series with r greater than 1, it diverges. So the series diverges. Series diverges. If series diverges, then the sum is infinity. So you don't need to write that. Diverge means if the sum is not a finite number, it is infinite number. Okay, it is infinity. That's why you stop here if it diverges. Okay, guys. All right. That's how we do examples related to the geometric series. All right. Thank you.